lesson is a lesson about array lists, and we'll start with just a quick review of arrays. Here's an example of an array. We use one called scores in our grades project, and we've used it many times before. So if we want to create this array called scores, we establish that this is going to be an array of ints. That lets you know it's an array. We're calling the scores, the array scores, and we say new scores, and we have to tell it the size we want. Our example here is 5, so I'll change that again to 5. 1, 2, 3, 4, 5 locations in the array scores, and they're indexed 0 through 4. So one thing you need to know when you create an array is you need to know how big you want the array to be. Suppose we made it 5 and we start filling in scores and we realize, oh, we have another score, we need a 6th spot. Well, we can't just in midstream now make the array a little bit bigger. We would have to make a bigger array and then copy everybody from this array into the bigger array and then start adding additional scores. That's one of the drawbacks of arrays. And ArrayLists kind of solve that problem for us. Another quick review about arrays. Arrays could hold primitives like ints, doubles, booleans, but they could also hold objects like strings, like dots, like cars, like trucks, like vehicles. ArrayLists can only hold objects. So if we want to create an array list of, let's say we want to create an array list of, I don't know, let's say vehicles or dots. Let's do an array list of dots. We can create an array list. And in these hard brackets or these angle brackets, we're going to tell it what kind of object you want in our array list. So this says we're going to make an array list that holds dot objects. We're going to give our array list a name. I'll call this our dot list. And that's equivalent to saying int x, that we have a variable x that is of type int. Actually, a better equivalency would be to say that that's equivalent to saying just this much here in terms of connecting it to an array. This is equivalent to saying scores is going to be an array of int. This is telling us that dot list is going to be an array list of dot. So scores is going to be an array of int. This says that dot list is an array list of dot. Okay. Well, that doesn't give us it doesn't even give us an array list yet. It just sets up that dot list is going to be an array list. So we then would need to say that dot list equals new array list of dot. And this then instantiates the dot list to refer to an array list. But at this point, the array list has no size. Just like we can say here for the array, we can say an array in our array called scores. We could say scores dot length, and that'll give us in our example would give us a 5. That there were 5 positions in the array. If we try to do dot list dot length, that will just give us an error. In the dot list, in the array lists, it's not called length, it's called size, and it's a method. And dot list dot size would return to us, in this case, at this point, it would return to us a 0. It has no size. There's nothing in the dot list. So there is a method called add. It's an add method. So if we were to say dot list dot add, and then tell it a dot to add to it, it would add that dot list. So let's add a new dot to our dot list. So that would add one new dot. But one of the things that is nice about, or one of the main things that's nice about an array list is that every time you add, the array list just grows dynamically. And if we remove, the array list shrinks. So the array list maintains its own size. It grows and shrinks as needed. For an array itself, if we run out of room, we're kind of stuck. We need to then make a new array. Normally the convention is to make it twice the size, and then to copy everybody from the original array into the new array. Big advantage for array lists that takes care of all that for you. So let's imagine that this particular null constructor created one dot, and it happens to be the red one. And there it is in my dot list. So dot list is referring to that array. If we were to put this in a loop, as it would add the next dot, and the next random dot, and the next random dot, and maybe the next random dot, and so on, provided, the way I'm kind of showing you this, I'm assuming that our null constructor picks a different color every time, or not every time, but it randomly picks a color. I only have 4 colors here on my smartboard, and the array list continues to grow. If we want to remove a dot, we can say dot list dot remove, and we tell it which index. So for instance, suppose we say remove dot list dot remove 2, that will remove the dot at position 2. And what's nice about that is after removing that, I wonder if I can make a copy of all this. Let's save that happens first. Probably not right. Let's try this again. Let me just pause. Okay, so I was able to copy this so that I could then show you what happens on when dot list dot remove 2 occurs. So this is position 0, position 1, position 2. This will get removed. Let me see if I can ungroup that and remove the second one here. Okay, so it's all one giant group. So let's do this if we can. We'll remove that guy. What happens is everybody else moves up. Everybody else moves up. So now, the dot that was in position 3 moves to position 2. So if I were to repeatedly remove position 2, then this guy would move up, this guy would move up until there was nobody left in position 2. Or anybody beyond position 2. So let's see a quick look at how remove works. It's a quick look at how add works, how to set up an array list. if we want to access members of the array list, I'm going to show you a couple ways to do that. So if we wanted to access that second member in our dot list, we could use .list.get and tell it go get the second member, which would really be the third member because it's 0, 1, 2. And that will return us the dot. So if we created a dot object or dummy holder dot called D, and D equals .list2.get, it will get us this guy right here, refer to that guy right there. And it'll get us that object, that dot object, out of the array list. It doesn't take it out, it doesn't remove it. It makes us a dot, a copy of that dot, and returns it to this location. Okay. We also could access everybody in the dot list using a for loop. And we can use what this is actually called a for each loop. So we want to take every dot in the dot list. So we need some variable to represent each dot as we take out of the dot list. So I'll call it every dot D in our dot list. So every dot D in the dot list will be accessed in that for loop. So then in our code here, if we want to work with each dot as we go through the loop, this will take us through the dot list starting at position 0, and D will become the dot in position 0. And then the next time through the loop, D will become the dot in position 1. And then the next time through the loop, D will become the dot in position 2. So this is called a for each loop. It will take us through every dot D in the dot list. And then we would be able to work with dot here. We could do dot D dot draw, like we've done in the past. And I'll show you an example of that next. Okay, so we're going to take a look at an example where we'll use an array list. If you remember, we had a dot tester applet. Let's see if I can run that. And that applet drew a couple of dots, randomly placing them on the screen. It created an array of dots, and I modified it to handle array lists. So here we originally created. I guess I erased it somewhere. Here it is. We originally created an array of dots called D, and we're going to do this with an array list instead. So let me go back up here. Here we go. So this was our original, I'll uncomment that so you can see it. This was our original array of dots. And my dot count is 10, so it created 10 dots. It created an array of size 10. And then we had to instantiate each of those dots. So it'll be similar with our array list. Here I'm establishing that dot list is an array list of dot. And in our init, in the past, we went through this for loop, and each dot I of D sub I, each member of the array, received a new dot. And we're going to do the same kind of thing, except we're going to use the add method of the dot list. So dot list dot add new dot will add a dot in position 0, then add another dot in position 1, and so on. It always appends to the end of the list. So that I have in our init, and that will create the array list of dots. And then in the paint routine, Let me comment this part out here. I don't want to erase them yet, so I'll comment this out, and we'll take a look in a moment at what that will look like. But here I'm using that for loop that we just talked about for each dot. So I'm going to use a variable called a dot, which is of type dot. And I'm going to use that variable to go through every member of the dot list. And this is how this for each loop works. It's really nice, concise, to go through every member of the dot list. And in the for loop and in the code here in the loop, I'm going to take a dot and draw it. So this will draw a dot. It'll draw the first dot in the list, and I'm going to pause, and then it'll go through the loop again and get the second dot and the third dot and the fourth dot. It'll get every dot in the list and draw them. So let's see what that looks like. I didn't mean to do that. I'm sure it'll work like this. I'll compile that, and then we'll run that. I'll compile it again, and we'll run that, and it should draw us 10 dots. Move this out of the way, and it drew 1, 2, 3, 4, 5, 6 dots. No idea why it should draw us 10 dots. We'll try that again. So if I run it again, we'll see if we get 10 dots. Yeah, that looks better. So notice this time it opened up the window to the size specified. We specified 800 by 800. That's why we couldn't see all the dots last time. Okay, I don't know why it does that. Sometimes it does that. All right, so let's go back and let's add in the code. We'll uncomment this so we can see. Here, I'm going to try and erase every dot. Now, I could do that with this for each loop, which I'm going to do. I'm going to do the same thing with this for each loop. I'll copy that, and I'm going to place this down here. I'll comment out this while loop, and I'll talk about that while loop in a second. And I'll put out for each loop right here. And I'm going to comment out the remove part here. And we're going to erase and pause, just like we did in this loop where we just draw and pause. So let me compile that. Yay, it likes it. And let's see what happens when we run this. So there's the 10 dots, and then it erases them. And then, of course, our applet runs again and draws and erases them a second time. So let's go back into this where we're erasing, and instead of using the for loop this time, I'll delete that. I'm going to use the while loop, and we'll talk about what I'm going to do with that. So I'm going to take the while loop, and I'm going to go through the while loop while the list size is greater than 0. So if the list size is greater than 0, that means there's at least one dot still in the list. And what I'm going to do then is I'm going to remove that dot. After I remove it, I'll erase the dot so we no longer see it. So this will remove the dot from the array list. When you call remove, I'm going to be removing the first dot in the list. That's the dot at position 0. Now remove the first dot in the list, everybody moves up. So if we remove the first dot in the list, it returns it, and a dot will receive that first dot in the list, and a dot erase will erase that dot. Then we'll pause so we get a chance to see it. As we come around the loop, the size will have gone from 10 to 9. And now there are 9 dots left in the array list. So this will remove the first one in the list again. Everybody's moved up. So the first one in the list will be the guy that used to be the second one in the list. And it'll erase each and every one as it removes each and every one. So at the end, the size of our list should be 0. So let's see what happens. Let's compile that. And before I run it, the other thing that should happen is it'll draw every dot, erase every dot, and then the second time it runs, since we've removed them all, maybe we won't see it unless it runs it from the start again, removing every dot, and it doesn't happen the second time because the list is empty at this point. We've removed everybody from the list. So that's our lesson for today. Hope you get an introductory understanding of what array lists are and how they work. We'll do some more with it next time.